Wildcats. This is an overview of Unit 0, Focus Question 3. So in this video we're going to be talking about how to make and support scientific claims. So I think a lot of you are familiar with this. You've worked with them before, CERs or Claim Evidence Reasonings. We continue to do them here as that's how scientists support themselves, but we will do an abbreviated version of them compared to what maybe you've done in the past. Okay, so let's just walk through this step by step. The very first thing in order to make a scientific claim and support it is you need to understand the question you're asking or what you're being asked to investigate. So you really need to look at what that question is and think about it. Is it asking you the relationship between two things? Is it asking you to make a prediction? Is it asking you to support or refute some claim? Like, what is it that it is? And that's really step one, is knowing the question that you're trying to answer. Oftentimes students, I think, will just do an experiment and collect data and then they write some stuff down, but they're not actually thinking about what am I trying to answer? And so I've got an example that we'll use throughout this video. And so in this one, we'll use a physics one. It is, what is the relationship between the coefficient of friction of a surface and the stopping distance? And it doesn't matter that you don't know what the coefficient of friction is. I mean, if you understand what friction is how does friction affect stopping distance is really what this is asking you. Okay, so that's what this question is. And so from that, it says, what is the relationship? So we can just kind of decide, oh, this is asking me, it's a relationship question. So how are these two things connected? Are they connected? Are they not connected? If they are, how? That's really what we're trying to find out. And so step two is going to be, we need to conduct an investigation to gather evidence. So you're probably well aware by now science is about not feelings, but what can we support with data. And so to do that, we need to conduct a good experiment to collect data that's going to help us not only determine what our answer is, but justify why that is the correct answer based on the data we have. Okay, so here in this example, since we're trying to figure out how the coefficient of friction or friction affects stopping distance, let's say we set up a lab that looks kind of like this, right? We roll like a marble or a car down the ramps that are the same height, and we do it onto 3 different distances. So it looks like wood and the carpet, and then maybe paper, something like that. And so we could either know or figure out the coefficient of friction for each of these surfaces, and then we could easily just measure how far the car stops. So now we're collecting data, right? It's what is the relationship between coefficient of friction or friction and stopping distance. So we've got some way to collect numbers, quantitative data about those things. Coefficient of friction will be a value, or friction, if you want to think of it that way, and then distance. Those are both things that we can measure, numbers that we can then use as evidence. So after we've conducted our investigation, we want to make a claim. Your claim is going to be a single statement that answers the question. And so to make our claim, we need to actually look at the data. So I have some data here. Let's say I graphed it. Okay, and then I can see, so I've got coefficient of friction, since that's what's changed, it would be my independent variable. And then I've got stopping distance on my vertical axis here. And to me, it looks like as the coefficient of friction increases, then stopping distance goes down. Right? So as coefficient of friction gets bigger, stopping distance gets smaller. And so that tells me right there is my claim. My claim is the larger the coefficient of friction, or as the coefficient of friction gets bigger, the stopping distance gets smaller. There. I mean, the question that they asked us 3 slides ago is, what is the relationship between those two values? Well, I just told you what the relationship is. As one gets bigger, the other gets smaller. And I did that because I have data from my investigation. So if this is my answer, the key to science is I need to support it. And so now we're going to make our argument, or our justification, or sometimes called the reasoning. So really what we want to do here is explain why our claim is correct. We're going to use 2 different pieces of evidence to do that. One is our data, right? Trends, not data points. So I want to talk about the overall trend, not any individual data point that I see in this graph. And then I want to use science-like principles and ideas and concepts. Data alone isn't enough if we can't explain why the data is the way that it is. And to do that, we use scientific principles that have already been established. And we link these two. And the connection or link between these two is our justification. So we justify our claim by not only using evidence, but also by using science. So I did an example of that, and you can see I've got them color coded. So first I'm going to start by talking about the trends that I saw. The stopping distance of the marble increased when the friction value, or coefficient of friction, of the surface decreased. So in other words, that is an inverse relationship. As one goes up, the other goes down. This makes sense, right? Oh, sorry, let me back that up. Notice, that is my trend, right? This is just one sentence that describes the trend. I didn't list all my data points. No one, if I want to see, if any scientist wants to see your data point, we'll look at your data table or your chart, summarize it for us. Uses scientific principles. So now I need to talk about why, like what science explains what happened there. So to me, this makes sense because friction is a force that acts in the opposite direction of motion. Newton's second law tells us that if mass is held constant, which is what we did in this lab, then a smaller force results in less acceleration. Now, I don't expect you to understand that necessarily. We haven't covered Newton's laws at this point. But hopefully what you can take away from this is I'm citing Newton's law to explain why I saw the trend in the data that I did. Okay, and then I've explained Newton's law. And so now, one sentence that describes the trend, two sentences there, a few sentences that cite like some scientific principle or idea that we've learned about, and now I need to connect them. That is seen in this lab because it takes longer for the object to accelerate to zero when the frictional force is smaller. And so now I've connected this smaller frictional force and stopping distance, which I saw, which is my trend, with this idea of Newton's second law. So to summarize, I know some students are not big fans of CERs because they feel like they're these big long things. This is 4 sentences. 4 sentences that make my argument of why this is the relationship and how I know that it is accurate or what had happened. Okay, so some things to avoid that I see students often do. Just science doesn't work in absolutes. Always, never, words like that. And oftentimes it's like science is in English in this way, in the sense that there's always an exception to a rule. Sometimes we haven't seen it yet, but there could be. Okay, so we don't want to say things like always and never. And so to that end, don't overreach. Don't say anything is proven. We can say supports, right? That data supports my claim, but it could be that if I did a different experiment, I would find something different. And so we haven't proven it. We just have said the data that we collected in this lab supports the claim that we're making here. The number one thing that students do is list data. Do not say the stopping distance was 0.9 meters when the coefficient of friction was 0.35. Don't say that, because that doesn't tell me anything other than one single data point. Tell me about the trend. The trend line shows that as coefficient increases, stopping distance decreases. This is seen in a slope value of, and then we could go on and talk about our slope value there. This is not a single data point. This trend line and this statement summarizes all of my data points. It is a much better reflection of what I'm seeing in all of my data than just listing a single data point. And just don't write 7, otherwise you got to write 7 sentences of this data point was this data point was this data point was this. No one wants to read that. We could see that in your table. This one sentence summarizes that. And then finally, don't leave underlying assumptions set. Don't assume your reader knows Newton's laws, right? Once you've learned them and are using them, tell us what Newton's law is. Tell us which ones you're using. State them specifically and explain how they relate to the trend that you're talking about. So it's important to really, that's just saying, explain your ideas. Don't leave things left unsaid. You don't need to write 17 paragraphs, but you need to tell us why Newton's second law supports it. It's not enough to just say Newton's second law supports this. Why does it? That's the key of making a good reasoning section. Okay, so hopefully this helped. Our goal here was to talk about what is a scientific argument, what are the steps, how do we make a CER, and what do we do during each steps. We went through an example of that, and then we talked about what are some mistakes that we want to try to avoid when making CERs.